But before designing or before solve any problem, we have to understand or we have to know about the assumptions and formulations and considerations of IS codes for column. So first of all, let's check out the clause number 39.3 for axially loaded short columns. After that, we will get back to this page and see this formulation, which is made on the basis of IS code assumptions. Okay. Let's check out IS 456 2000. Clause number 39.3 of IS 456 2000 for short axially loaded members in compression. That means axially loaded short column. Let's check out the assumption. The member shall be designed by considering the assumptions given in 39.1 and the minimum eccentricity. When the minimum eccentricity as per 25.4, that means clause number 25.4, does not exceed 0.05 times the lateral dimension, the members may be designed by the following equation. So before check the following equation, let's check out as per clause number 25.4 what is minimum eccentricity. Look, clause number 25.4 minimum eccentricity. All columns shall be designed for minimum eccentricity equal to the supported length of column by 500 plus lateral dimension by 30, subjected to a minimum of 20 mm. Where biaxial bending is considered, it is sufficient to ensure that eccentricity exceeds the minimum about one axis at a time. So whatever written about minimum eccentricity, that is formulated in our notes. After read out all considerations of IS 456, we will see the formulated format of this written one. Okay, that is L by 500 plus D by 30 greater or equal to 20 mm, whatever written here. So let's check again. Let's continue clause number 39.3. So as per clause number 39.3, the formula is PU is equals to 0.4 FCK into AC plus 0.67 FY into ASC. PU is axial load on the member. FCK is characteristic compressive strength of the concrete. AC is area of concrete. Fy is characteristic strength of the compression reinforcement, and ASC is area of longitudinal reinforcement for columns. Now see here, whatever we read in IS code, that is written here for axially loaded short column with rectangular ties. The short column or lateral ties shall be designed by the following equation. If the minimum eccentricity does not exceed 0.05 times the lateral dimension, that is E suffix min, that means E minimum eccentricity is equals to L by 500 plus D by 30 greater or equal to 20 mm. So E minimum is not greater than 0.05 D. So, as per clause number 25.4, this formulation is written here. After that, Pu is equals to 0.4 FCK into AC plus 0.67 Fy into ASC, which we read out just in IS 456. Pu is factor axial load, AC is area of concrete, ASC is area of longitudinal reinforcement of column, FCK is characteristic strength of the compression longitudinal reinforcement. If the minimum eccentricity is greater than 0.05 D, the section is designed for combined axial load and bending. Okay. Note that minimum eccentricity as per code is equals to 20 mm. Therefore, 0.05 D is greater or equal to 20 mm. So, D is greater or equal to 20 by 0.05 or 400 mm, and here D is lateral dimension, as you know. Also, L by 500 plus D by 30 is less or equals to 0.05 D or D by 20. So, L by 500 is less or equal to D by 20 minus D by 30, or we can write 0.016 D. So, D is greater or equal to 0.12 L, where L is length of column. Hence, all column which have D, the lateral dimension, is less than 400 mm or 0.12 L, the minimum eccentricity will be greater than 0.05 D, and hence equation 1 will not applicable in that case. Now check out the design steps. How could we design? Now steps for axially loaded column. So, if factored load Pu is given and material the grade of concrete and steel, first assume suitable percentage of area of steel ASC. It will be vary between 0.8 to 4%. Maximum of the time generally we take 1% for easy calculation. Okay, and ASC is definitely P into AG, where AG is gross area. Now determine AC in terms of AG. So AC means area of concrete, which is definitely in between AG. So AC is equals to AG minus ASC. You can write it. Now calculate AG as follows. So from this equation, which is given in 39.3, Pu is equals to 0.4 FCK within bracket AG minus ASC, that means AC, plus 0.67 Fy into ASC. So we can write it, right? Now putting ASC is equals to P into AG. Now calculate AG as all other terms are known. So number 4, calculate dimension of column as follows. For square column, B square equals to AG. For rectangular column, B into D is equals to AG, where assume B and calculate D. One value we should assume and one we have to calculate. Now provide area of reinforcement and then design as per IS code. Design the lateral ties as per IS specification. Now note that if length of column is given, then we have to calculate effective length on the basis of end condition or support condition, which is given in table number 28. No, where is written 13.1, not that is wrong, given in which is given in table number 28 of IS 456 2000. This will be table number 28. Okay. Then check the slenderness ratio and minimum eccentricity as follows. L effective by B should be less than 12. After that, calculate minimum eccentricity as follows. E minimum is equals to L by 500 plus G by 30 is greater or equal to 20 mm, and E minimum by G is less or equal to, it's less than 0.05 for an axially loaded column. Now we can use design aids like this. The equation which is written and earlier, the equation 1 given above can be rearranged as follows. So the equation can be rearranged as follows. Pu is equals to 0.4 FCK within bracket Ag minus ASC plus 0.67 Fy ASC, where Ag is gross area of column. Now putting ASC is equals to P into Ag by 100, so Pu will be equal to 0.4 FCK within bracket Ag minus Pag by 100 bracket closed plus 0.67 Fy into P into Ag by 100. So Pu by Ag is equals to 0.4 FCK plus P by 100 within bracket 0.67 Fy minus 0.4 FCK. So we can rearrange like this. For varying values of Pu, Ag and FCK and P, for different value of Fy, design charts have been prepared which are used for design of short axially loaded column. These charts are given in SP16, chart number 24, 25 and 26, which are mainly used for this. Let's solve few problems to better understand the design of RCC column. The first problem